Hey, this is Keith with NetworkEngineerTraining.com, and today we're going to go over a SIP authentication attack. This is also the basis for a SIP authentication relay attack, but we're going to go over how endpoints that are exposed to the internet are vulnerable and what you can do about that. There's a couple of tools that I'm going to use in this video. The first one is SIP, which is used for SIP load testing and building different SIP-based scenarios. There is a soft phone that I'm using on my virtual machine called Twinkle. It's just a basic Linux soft phone. Going to launch Wireshark to do a packet capture. There is a small script that is written in Python, and there's also a link there for the IETF draft that explains how the SIP digest authentication works. It goes into a little bit more detail than what I'm going to go to in this video. So, obtaining the authentication credentials. Obtaining a full authorization header from a user agent can be the basis for a much larger attack. If the attacker is able to gather all pieces of the MD5 hash, they can perform a dictionary attack to determine the Auth-Password. Now, this can be performed offline after they sent the initial invite and they've gotten your authorization header. This works better for the attacker, as the end user will only experience one strange call where they maybe didn't have audio on that versus a flood of random invites. And as I mentioned earlier, this is a similar technique that is used for SIP relay attacks. And the attacker can rely on an invite, an update, or a buy to obtain the user credentials. Using invite or update will require a little bit of social engineering or setting a session refresh timer that relies on a refresh from the UAS. Who is vulnerable to this? Really, anyone with their IP phone open to the internet, anyone with an IP phone that responds to an invite from an unknown server, and the best practice is to lock down your IP phones to only respond to an invite request from the registration server. And really, any switch/PBX admin who sets the auth username and the auth password to the same value is especially vulnerable. It's just as bad as using a standard password out of the dictionary using that. It's not a good practice, and you shouldn't really ever do it. Well, don't do it ever. Basically, this is a ladder diagram. The attacker is going to send an invite over to the IP phone. The IP phone is going to go through the standard call setup. It's going to do a 100 trying, a 180 or a 183 for ringing. They're going to answer with a 200 OK. There's going to be an ACK from the attacker, and then there's going to be RTP, or in this case there's going to be RTP, but I'm not actually going to send any audio, which is what an attacker could easily do, because you answer the phone and you'll talk for a minute, say hello a couple of times, there's nobody there, and you're just going to hang up the phone, which is what happens in this scenario. They hang up the phone, it sends a buy, the attacker then sends a 401 unauthorized, and the IP phone is going to send a buy with the auth header in there. Quick overview of what we're going to see in here is, like I said, I'm going to use SIP to send the 401 authorization required, and I'm also just going to listen with Wireshark to try to pull this header out. But these are the fields you're really looking for. Is the 401 authorization required? We're going to set just a realm name of attacker, and I'm just going to send a nonce in there, just a random value, and we're going to see what happens there. Now, one last thing before we go into this, one quick overview on how the MD5 response is structured. Without QOP, it's like this. The first hash is a hash of the username, the realm, and the password. The second hash is a hash of the method and the URI. In this case, the method is going to be a buy. And the third hash is a hash of the first hash, the nonce, and the second hash. If you're using QOP, it's going to be a little bit different on the third hash, which is right here. The third hash is a hash of hash 1, the nonce, the NC, the C nonce, the QOP, and finally hash number 2. So let's get started on this with SIP. Let me load up my scenario here so you guys can get an idea of what this looks like. SIP digest leak. And yeah, I have it open in another window. So what this is going to look like is, this is a basic SIP scenario. I am going to set this to send, and I'm going to send an invite. All of these fields that are in brackets are going to be passed as arguments when I launch the command line. we are going to expect a response of a 100, a 180, or a 183, and then we expect them to send a 200 OK back to us. We then send an ACK, and there's just going to be dead air, and so we expect a buy. When that buy happens, that's where we send this here, the auth header with these fields set, the realm and the nonce. And then we expect another buy, and then we are going to send a 200 OK to tear down the call. So I've already got this all pre-typed out here, but what this is, it's just the program name, the IP of the remote phone or the remote user agent, -I is the local interface IP that we're using on this machine, -S is going to be the service. In this case, it is going to be, let me scroll up here, where is that? Invite right there. So it's going to be part of the URI. It's going to essentially be the phone number on this one. And -SF, that is the scenario file, and this is a scenario file name. -M1, -L1, those just mean I want to send the call once. I don't want to do an invite flood. So on the other side here, let me just go in here really quick. So the phone number that I'm setting this up with is, I don't know how well you can see this, 480-100-1234. You look down here, that's what I've got as well, 480-100-1234. Authentication username, I've got that in there, and then the password, it's already entered in there. Let's just say I don't have any idea what it is. It's going to be just a standard dictionary-based password for this scenario, but that's what we've got in here. So we're going to launch this, and I've now got my call coming in. Got my call. There's nobody on the line, so you know, let me actually start Wireshark here so we can see what this header looks like. I missed the first part of the call, but that's perfectly fine. I don't care about the invite. All I really care about is the buy. So here's the buy. Here is the 401 authorization required, just like in SIP. As you can see, all of these fields have been populated. And now we receive a buy with an authorization header. We're just going to copy that, and we're going to throw that into, and that's right here, just so I can see it a little bit easier. And so we're going to launch this basic Python tool that I've got. What it's going to do, let me, I launch it without any arguments. It's just going to pop up syntax in the order that I want everything seen in. But if you want to go and look at the actual tool here, it's pretty basic. We're passing the arguments in there. We're opening up just the Linux dictionary or words file, and we're going to take every entry in there, and we're going to go over and create an MD5 hash over every single entry in there and see if the password or the response that we're seeing, if it matches up with any of these hashes that I'm creating. As the important part that we want to get to match up is this guy right here, because that means we figured out what the password is. So we're going to launch that with SIP md5_dictionary.py. The first parameter argument is the username. It'll be a super secret username. The second one is the realm, which is attacker. I don't have my keyboard shortcuts set up on this terminal, so don't mind me. The method is going to be buy. The URI is going to be right here. Now the URI has to be what you're seeing in the auth header. Can't just put some random value in there. And the nonce, maybe right there. And finally, we want our response to be passed along to. And as I said, this is just going to go through, create a bunch of hashes using line by line through the dictionary. And when we get a match, it's going to hopefully pop up and say this is the user password, just because it figured out a match on the response. And looking through the Linux dictionary, you can see how fast that was. The password comes up as Pharaoh, which is just in the Linux dictionary. I picked something that was halfway down just to see how fast it would actually search for it. So, JR. As you can see, this is a fairly long file that we've got here. But that's basically how you can figure out the authorization credentials needed for a SIP phone that's exposed to the public internet. Now, if you are using something like a Polycom phone, which I tested the same SIP scenario on a Polycom phone, which I don't have here at home with me, but it was a VVX 600 with firmware 4.1.3. It behaved the exact same way. Now, with the Polycom, though, in the contact header that I was sent, it also happened to say the proxy that it uses to register with. And so that would leak out a little bit more detail there. So with that, I'd be able to figure out the username, the password, the auth password, the proxy you need to register to, and I could easily jump on and start making calls. Now, clearly, anybody who's running a SIP-based network should be using a very secure password, using as many alphanumerical characters as they possibly can for the username and password, as doing a dictionary-based attack becomes much more difficult. Somebody would have to write a tool that's just sending random values, and who knows how long that would have to run. So, in a nutshell, this is an easy way to figure out if somebody is using a very weak authentication username and password. Until next time, this is Keith at NetworkEngineerTraining.com. I hope you enjoyed this video. Thanks.